Okay, in example 2 here, we're going to use partial fractions with repeated linear factors. So again, we're going to take this right here. We've got a rational function. We're going to take the denominator and we're going to factor it as far as it goes. So x cubed plus 2x squared plus x. The first thing I can do is factor out the x. Get x squared plus 2x plus 1. And then I can factor that. And I get x plus 1, x plus 1. Okay. So this is x times x plus 1 squared. Okay. Now we're going to take this function, 5x squared plus 20x plus 6 over x cubed. Well, actually, this is just write it like this: x times x plus 1 squared. And then this is going to equal, now one of my terms is just x, so it's going to equal a over x. My next term is x plus 1, so it's going to be b over x plus 1. And then I have to have another term. Since this is squared, I have to have 1 for the original term, and then I have to have 1 for the squared term. Okay. So then what we would do is we would multiply this entire thing here by x times x plus 1 squared. That's going to cancel out all this and leave me with 5x squared plus 20x plus 6 over here. The x will cancel the x and leave me with a times x plus 1 squared. And then the x plus 1 will cancel one of those x plus 1s and leave me with b times x plus 1. And then the a plus 1 squared will cancel that and leave me with c times x over here. Okay, now what I want to do is I want to find out, okay, what's going to make any of this 0? So let's see, if I plug in -1, that makes this 0. I'm sorry, it makes, if I plug in -1, that makes this 0 right here. So it makes this term go away. It also makes this term go away and leaves me with just c times x. So if I plug in -1, so we'll go let x equal -1, then this side becomes 5 minus 20 plus 6 equals, again, remember if I put a -1 here, this is just 0 and that makes this whole thing 0. If I put a -1 here, it makes all this 0. And that leaves me with c times -1. And this I can see is -9 equals -c, and so c is 9. So now I know what c is. Okay, the next thing that I would probably do is I would let x equal 0, because that'll blow up this term and it'll blow up this term. So if I let x equal 0, this becomes 0 plus 6, so that's 6 equals, let's see here, if I plug in 0, I get 1 squared is 1, so I get 1a, so just a. And if I plug, let's see, 0, that goes away and that goes away, so I just know that a is 6, so that was easy. Okay, now I have nothing left that will make all of this go away. So what I can do is I can just pick any other number that I want. I'm going to pick something super easy. Okay, I'm going to let x equal 1. So if x equals 1, this is 5 plus 20 plus 6, that's 31, equals, okay, I know that a is 6, so this is 6 times 1 plus 1 squared, so that's 6 times 2 squared. 6 times 4 is 24. And then if I plug in 1 here, I get 1 times 2, which is 2 times b. Okay, so that's plus 2b. And then remember, c is 9, so this is 9, and remember x is 1 over here, so this is 1 times 9, so this is just 9. So then 31 equals 33 plus 2b, and so negative 2 equals 2b, and b is negative 1. So now I know what all my variables are. So now I can write out my partial fraction equation. Okay, so the integral of 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x dx is equal to the integral of 6 over x dx, because remember a was 6. And then let's see, b is negative 1, so that's going to make this minus the integral of 1 over x plus 1 dx. And then c was 9, so this is going to be plus 9 times the integral of 1 over x plus 1 squared dx. And I would prefer actually to write this as x plus 1 to the negative 2. Okay, I can actually take this 6 and pull it out here. Okay, and now this is pretty easy to integrate, so it's 6 times the natural log of the absolute value of x, okay, minus the natural log of the absolute value of x plus 1, minus, or plus 9, well, actually it's minus. Why does it become minus? Because when I integrate this, I'm going to get x plus 1 to the negative 1, but I need a negative out in front to cancel that when I take the derivative to make that positive. So this becomes negative here, plus c. And now I can kind of, clean this up a little bit here. Okay, so I can make this 1 natural log here. So it's natural log of the absolute value. This is x to the 6th divided by x plus 1. And then this is minus 9 over x plus 1 plus c. And there you go. We've solved it using partial fractions.